Alright class, welcome back. Today we're going to talk about piecewise functions. For some reason this is a difficult topic for some people, even though it should be not that bad. And I'm hoping that what we do today will make it easier for you. Basically, a piecewise function is a function that's split into different domains here. So if we're looking at this first one, we have our function f of x is equal to this 3x plus 1 whenever we have a value of x less than negative 3. However, it changes. Between negative 3 and 5 we use this function. And then when we take 5 and go bigger than 5 we use this function down here, x minus 7. So it's just taking pieces of functions for different x values. So for the first part, if we're just evaluating, we want to find f of 2. This means that my x input is 2. Well, I look on my list, that would go with this one here. 2 falls between negative 3 and 5, so I'm going to use that function and put a 2 in instead. So my value is 4. If I look for let's go to b. b is negative 7. Negative 7 is less than negative 3, so I'm going to use the 3x plus 1. So I'm going to throw that in. So I get a negative 21 so negative 20 is what the function is at that point. If I look at negative 3 now, be careful. Negative 3, this does not include negative 3. This one does because of the equal sign. So, because of that, we have to use the 2x again. Negative 6 is my answer. And then finally, we look at 9 for x, 9. And that's bigger than 5, so we're going to use this function here. So I'm putting 9 minus 7, and I get 2. So again, all it is are a bunch of pieces of functions. You have to use the function that's correct given the x value that I give you. Okay, now we're going to look at the calculator for these problems here. Graph the function. Now, the easiest way I find to do these is to just plug in the function you want to look at first. So for example, I'm going to plug this into my y1, and then I'm going to graph it. So 2/3 x plus 2. Now here's the problem. When you graph it, you get the line for the whole thing, right? But I only want this line for values where x is bigger than 2. Here's the easiest way to do that. Go to your table. Your table is where your graph button is. Just hit second graph. And here's my table. Okay? But we only want values at 2. So when I plug in values at 2, 2 is 3.33. 3 is 4. And then I'm going to actually start at 2, but then I'm going to go to 3, 4 and use the slope. You can keep plotting the points if you want that are on here as well, or pick the nice ones. So 3, 4, 6, 6. But the beginning point is 2 and 3 1/3. Now, you have to look at what we have. Are we including 2 for this graph? No, because there's no equal sign here. So, like I said, it was 2 and 3 1/3. That's going to be an open hole. And then I had 3, 4, and I had 6, 6. So this should be a straight line, and you know that since it's linear, it'll just keep going. And again, if you wanted to plot more points, you can. The important thing is that you have the starting point, and it's an open hole because there's no equal sign. It's not equal to it there, and it goes on forever linearly. What else do I need to say about that? It doesn't stop either because x is bigger than 2 goes on forever. Alright, so now let's look at the other graph, shall we? Let's look at let's look at the other one. So I'm going to type in negative x plus 1, and I'm going to graph that. Now again, we don't want anything over here because we already took care of that spot. We want all the x values at 2 and less than 2. So I look at my graph or table, second graph. I always look at where it's supposed to start though. It starts at negative, so 2, negative 1, 1, 0, 0, 1. So that's what it's doing. So 2, negative 1, 1, 0, and 0, 1. So 2, negative 1, and it is a filled-in circle because it equals to 2 there. And then it's a negative slope. So 1, 0, 0, 1, and basically it's going to keep going like this because it's a negative 1 slope, which means that it's going up and to the left like this. So what we would do is graph this piece. And since it's going off forever, we need an arrow. And that is the graph of this piecewise function. The blue piece is a line. You guys know how to graph this line if it was a full line. Same thing with the orange one. However, we want the piece of it from 2 onward for the blue one, and we want the piece of it from 2 to the left. Okay, so let's look at this next one. This one you don't really need a graph to look at. What f of x is, you have to think of this as like y equals, is your f of x equals. So y equals 1 between negative 4 and negative 3. Well, y equals 1 is a horizontal line. Okay, and you can graph this if you need to on your calculator. But I'm at negative 4, y is equal to 1. It's filled in because it is equal to. And then we go to negative 3, which is not filled in because it's not equal to. And you connect the lines. There's my horizontal line. Now, y equals 2 when we get to negative 3. And we go all the way to negative 2 and put an open circle because it's not equal to again. And finally, y equals 3 when it's negative 2, and we go to negative 1. And again, you can graph each line individually if you want, but these are just horizontal lines. There's no x values. So that is how you graph that one. Okay, let's flip the page. This gets a little trickier. Not too bad, though. We have a little bit more going on. So let's graph the next one. So I'm going to enter my absolute value first. Let's do the absolute value first. So again, absolute value is under math, and then move over one, and there it is. 2x plus 4. And I'm going to graph that. Okay. Now, from our lesson, we didn't actually do anything with a 2 inside, so it wouldn't shift over 4, it actually shifts over 2. But there's my absolute value. So go to the table to get your values. And we want to start at negative 7. Okay, negative 7, it's at 10. But it stops there, right? It says x is bigger than negative 7, which means we're going to the right. X being bigger than negative 7 means we're going towards the positive. So we basically need to plot all these points, and then hopefully you guys see that the vertex for this absolute value is at negative 2, 0, because then it starts bouncing back up. So I have negative 7, 10, negative 6, 8, negative 5, 6. I'll start graphing that. Now remember, negative 7, 10 has to be an open hole because it's not equal to. And then we have negative 6, 8, negative 5, 6, negative 4, 4, negative 3, 2, and then we said that the vertex was at negative 2, 0, and then it bounces back up. And since this is going off forever, and you can see that the slope then is just 2, x is bigger than negative 7, that's everything that way. So I'm going to just make my absolute value. And you need an arrow because it's going off forever. So we took care of almost this whole graph with that piece right there. Now we have to look, and we're kind of going backwards here. We want to look now between negative 8 and negative 7. Well, between negative 8 and negative 7, we just have a number 3. So that's saying y is just equal to 3. So we have another horizontal line between negative 8 and negative 7. So here's negative 8, negative 7. The horizontal line's at 3. So you just have to figure out then where the open hole is and where the closed hole is. Negative 7 is where the closed hole is. And sometimes they're both open or both closed. But in this case, there's one open and one closed. At the negative 8, it is open. And finally, we have our last piece, which is just a linear equation. So put in the linear equation. So negative 1/2 x plus 2. Graph it. And again, we don't want that whole line. We just want anything from negative 8 on. So we're going to look at our table. And we want negative 8. So at negative 8, it's at 6. and at negative 10 it's at 7. So you can plot those 2 points and then connect the dots. Well, and you also need the arrow to keep going after that. So negative 8, 6, negative 10, 7. And for negative 8 is also an open hole for this one because it's not equal to. Negative 10, 7. So there's my last piece. And again, it'll go off forever because I want every value less than negative 8, which can be negative 20, negative 25. And that's my graph. That's it. Alright, the challenge one. If you guys want, you should pause the video now and try this one on your own, and then see what you get. Obviously use pencil because you don't want to use pen and make a mistake. Alright, so first things first. Pretty easy part. We don't even need a calculator for this one. We have another constant. The y equals negative 8, or f of x equals negative 8. So I'm going to go down to negative 8 for all the values when x is less than negative 7. So that means that here's negative 7. It doesn't equal to it, but everything less than it is going to be negative 8. So it's a horizontal line starting there and going off forever. Okay, so we got that piece down. Next we have a negative absolute value. So we need the calculator again. So we're going to, actually let me slide this over here now. So now we're going to do our negative absolute value of x plus 3. And we graph it, and it's an upside down one because the absolute value is on the outside. So we're going to look at our table of values, and our table starts at negative 7. So we want negative 7, negative 6, negative 5, negative 4. And as you see, you can see the slope is 1. As it goes over 1, it goes up, or up 1. Until we get to negative 3. Negative 3 is the vertex at 0, and then we keep going. So we only want to go from negative 7 to negative 1. So I could actually look at all the points I need to plot right here, because the thing says negative 7 to negative 1. So it starts at negative 7, negative 4. The vertex is at negative 3, 0. And then we're going to bounce back down all the way to negative 1, negative 2. And it's going to be a closed hole at negative 7 and an open hole at negative 1 because of the equal then or not. So we have negative 7, negative 4. And it's closed. And then again, there was a slope of 1 until it hit there. That was the vertex. There are no arrows on this one because we're just going from negative 7 to negative 1. And then we ended with an open hole here. So again, we're just taking a piece of the absolute value graph. That's it. Just pieces. So that was the orange one. Now we threw you a little curveball. We have a quadratic. Not a big deal though. Same process applies. I don't care what I give you. Just use the calculator and plug it in and get your values. We're only going from negative 1 to 3. So enter your quadratic in. X squared minus 1. Graph it. Obviously we're not using the whole graph. We're starting at negative 1 and going to 3 only. So I'm going to look at the table and go negative 1. I'll get all the points on here. Why not? There they are. So negative 1, 0, 0, negative 1, 1, 0, 2, 3, and 3, 8. That's what I need to plot. So this is telling you what to plot. I'm going to go down over here. I'm going to use green for this one. So at negative 1 it was 0, and it was a closed hole because it's equal to negative 1 there. At negative 1 it was 0. At 0 for x, I should say it's negative 1. For x of 1 it was 0. For an x of 2 it was 3. And for an x of 3 it's 8. And here's an open circle. And again, this is a quadratic, so it should look like a parabola. Don't give me straight lines. It's a U shape. Alright, so we got that piece done. And again, you can do this by hand too. If you plug in the numbers into here, if you plug negative 1 in here, you get negative 1 squared is 1 minus 1 is 0. So negative 1 is 0. You can do it by hand, but the calculator just gives you the values for you. So do that. Alright, so last one, now we have just a line. So I entered my equation, 1/3 x plus 5, and then I am going to see what my points are. So I'm going to look at my table. And I want to start at 3, positive 3. There's a nice starting point here. 3 is 6. So it's 3, 6. Now, for a fraction like this, you see how you get these weird numbers. You don't want to plot all the weird ones. Just plot 3, 6, 6, 7. And then draw a straight line, because it's linear. You can do that. Alright, so, and it is greater than 3, so it's going to be an open circle again. So there's going to be 2 open circles at 3. So 3, 6 is right here. Open circle. And then the slope, you could also graph it by slope. You know, now the slope is 1/3. 1, 1, 2, 3. 1, 1, 2, 3. Now, you can't go the other way, though, because this is a piece of a function. And that goes off forever. So that is what your graph should look like after you graph all 4 pieces. Okay? I hope the color coding helped. Again, I'm probably going to have 1 or 2 of these that you guys do in class when you get in. Like, I want to check them, almost like for a grade. We'll see what we do with that. But it's very important that you know how to use your calculator, understand what's happening. We're just graphing lines, and you can take each piece and solve it. Now, down here, you don't have to really do anything. This is just for if you want to see how your graphing calculator could actually do the pieces. You can follow these instructions and see how it will actually graph them in individual sections. You do not need to know this for the test. You do not need to know this for anything. This is more just an interesting little way to use the calculator. So if you want to do it, you can. If you don't worry about it. But just fun little thing to explore if you want to try it out. Okay? And that is it.